WWT presents Experts.
Hey everyone, and welcome to another episode of WWT Experts. I'm Matthew Coble, your host as usual, and today I'm delighted to introduce two experts from Worldwide Technology in this episode of our four-part series about the energy and utility industry and how organizations in that space approach things like artificial intelligence, lifecycle management, operational technology, and today's topic, security. With me are two experts. First, Adam Nathan, who leads Worldwide Technology's energy and utility practice. He's worked with our clients on business and technology strategies for over 8 years now. And as I've gotten to know him, I've found him to be really highly analytical and an intellectually curious guy. And I like that he's passionate about both modernizing the industry in general, but also making sure that that's achieving kind of important outcomes for culture and society for all of us, which is awesome. Also joining us is Carlos Sanchez, who's been in operational technology and critical infrastructure for over 30 years. He started his career in the U.S. Air Force, and he's since worked with other technology organizations in the private sector. Joined us here at Worldwide late last year, coming to us from Fortinet, based in Houston, Texas. Gentlemen, welcome. Thanks for joining us.
Hey, thanks for having us.
Thanks for having us.
All right, well, let's jump in. So first question for you, what are some of the challenges related to cybersecurity that you're seeing today in the energy and utility industry?
Well, yeah, I'll get kicked off here. I think, much of the grid was designed and deployed before anything was digitized. And really, we've been retrofitting most of it with digital capability for decades now. Deployment of new technology can take many years, decades in some cases. So we have to constantly manage multiple generations of technology. And on top of that, some of the applications that are used to manage the grid are made they're either bespoke or niche, and the OEMs are not always upgrading the underlying stack. So I'll give you an example. There is one of the major OEMs making wind power systems. The control system is built on a Windows 2008 operating system. And as of the last year or so, if you went to anything newer than Windows 2008, it was in breach of support, and the OEM would not support it for new deployment. Right? And you're going to run that system for 10 years. So we're talking 2033, you're still running a Windows 2008 system in all likelihood. So this is not always a decision made by the utility. This is where the market is in many situations. And so many of the assumptions that we make in IT security about the kind of data that's available, the communications being used, right, the context that we so often use for monitoring and visibility and then the action to be able to take, a lot of that doesn't hold in the OT side. And so it's really about looking for solutions that can work in these multi-generational, multi-technology generation environments with especially older communication systems. And at the same time, while that complexity on the back end is happening, attackers are growing in number and complexity. And as these companies continue to deploy more and more digital technology to be able to have a more reactive and proactive grid and handle greater volatility on the supply and the demand side, all of that is happening simultaneously. And so the attack surface is growing rapidly while the attacks are growing and the foundational underlying technology remains much of it older. So it really is a very difficult situation that the utility CISOs and operators are in as they try to keep the grid secure.
Yeah, under nature, we're talking critical infrastructure. So there's a limiting factor in the amount of time that the systems can be down. There is an expectation that they will be up all the time. Again, you want your power, you flip the switch, it has to work. And as Adam said, the length or the lifespan of these systems, you don't go around, saying I'm gonna change my light switches in the house, in any period of time. So the fact that we're dealing with critical infrastructure, the fact that this is a consumer service, I mean, not only that it limits what you can do in modernization, but also have to take it into consideration. It is a business, it has to stay up, and to secure it and introduce new technology, I mean, requires a lot of planning. And at that point, this is where we see a challenge, and a challenge that we definitely can help is bringing out all the new technologies, helping the operators and the subscribers as well. I mean, getting more immediate services and enhance, I mean, the infrastructure. So we see that, I mean, that quite a bit, especially in the substation in the United States and outside of the United States. Interestingly enough, outside of the United States, we see that perhaps, I mean, they're leveraging that infrastructure for other services, which again opens a new attack vector. I mean, when you start selling, let's say, internet over power lines and all that stuff. I mean, so that opens, yeah, there is a new revenue stream, but at the same time, I mean, it enlarges the attack surface.
All right, well, how can organizations out there kind of balance the modernization needs they undoubtedly have while still mitigating the security risks that they see for their infrastructure?
I think one of the areas is one of the biggest pieces we've seen help drive success there is really integrating security organizations into early stage technology discussions and business operations. It's for a long time, those have been separate. And I think and there have been some foundational rules. You put a firewall everywhere you can, right? There's some foundational things that have just been sort of blanket put forward by security. And then it's up to the other technology teams to figure out how to operate within those rules. Now, with architectures changing on the OT side, with more modern technology coming in, and frankly, with OEMs coming out with more innovative solutions that can enable security while enabling modernization, coming with those ideas from the beginning and being able to talk through what architecture keeps risk low while enabling that modernization is really important. It's no longer a set of rules and guidelines that just blanket work across everything. It really needs to be that iterative, collaborative discussion between these groups throughout the architectural process.
Yeah, in the industry, that is known as security by design. And what we see is that a greater collaboration between the OEMs and the user community. It's interesting because that didn't exist, especially in utilities. In the good old days, I mean, all this industry, you know, the manufacturer will supply a particular device without security in mind. And what we see now is that they're taking the input, I mean, from the user community, from the business itself, and there's an actual formalized process. I mean, that a device, I mean, as it's produced, the security is taken under consideration. So yeah, it's moving slow, but it's moving. We see some progress in developing new products.
Well, as each of you talk with clients in the energy and utility industry, you know, what advice are you giving them around best practices to get an accurate inventory of all the IT and OT infrastructure devices and so forth that they have, and sort of mapping that into the overall security that they may have to kind of make sure the organization can move forward successfully?
I'll take that one. I believe that the rules, some of the rules of IT or some of the best practices of IT do apply. There is some parallel in the OT business and in the critical infrastructure business. Everything starts with visibility. I mean, if you don't see it, you can't protect it. That's pretty much it. So and as we start, even when we start applying some industry architecture models and best practices, always the best practices start with good visibility, have a good as is. Once you have visibility of the environment, then you can control it. So that's the second step. I mean, you can steer the traffic, you can implement some security measures like firewalls, IDSs and such, but everything starts with visibility. Then you move to control. Once you control it and you can steer traffic, then you can start gathering some information, get some actionable intelligence, I mean, from the sources, or I mean, from the devices themselves. And in future state, of course, or the desired state, is make the environment as self-healing as possible.
Yeah, and I think we're at a time now where this is one area I feel like there are several solutions around that can really help. There are tools that can look at not just on the IT side. I know on the IT side, we've seen this for a while, where they'll look at data coming off of the network about a device, the kind of traffic, the frequency of the traffic. They'll dissect the packets and then look at the signature to then diagnose what type of asset it is, and they can get very specific. And fortunately, there are a number of OEMs who have done something very similar on the OT side. It's often much more limited information that we have access to. So, but they have built the capability and used things like AI to look for those signatures within all of that data to be able to say exactly what device is connected to that network. So that's one piece, is looking for the right tool sets to be able to capture that information, but also partnering with the operations teams so that you can get as accurate as possible front-end information about when things are deployed, what was deployed, where it is, what's the context within it, what's the configuration, and so forth. Maintaining as there's tickets to go make changes, or configuration management, patching, so forth, that's kept up to date. But we also see that going in the reverse. The folks in the field want that asset context. They want that data. They need it for their own operations, for their own lifecycle management, for their own troubleshooting when there are issues. So that same exact data that can help in security operations can really be of value in network, or in endpoint, or in grid operations. And so working together to set up the right stack and processes to capture that data up front and maintain it over time and test the quality of it in an ongoing fashion to identify gaps and issues, to ultimately get that trust factor from the organization that, yes, our asset database is accurate. That is really important as well.
I'm really encouraged, also with the applications of artificial intelligence in this field. And the possibilities are endless. I see that one thing that we didn't look at in the past was behavior. And right now, with the application of AI, we can see behavior changes and make cybersecurity decisions based on the changes on behavior of a particular device. And the attack surface and the vectors are a lot different. An oscillation in clock can cause some massive consequences for the grid. And when we start seeing the progression and getting data points over time, we can create models and say, okay, now we know that there's a potential breach here based on the behavior of that device, that it might not be something as severe. It might be something that oscillates and changes over time. And we can get alerted on that. That's the beauty of the application of AI into critical infrastructure. We can see behavior changes.
Well, Carlos, I want to kind of drill in on that a little bit. We have an episode of this series on AI, but for you specifically, are you generally optimistic that AI will help the security posture of organizations like this? Or are you pessimistic that the adversaries out there are going to use AI in interesting ways to attack the infrastructure in ways that we don't even know about yet? What are your thoughts there?
Yeah, foundationally, AI is a decision support system. That's the first job of AI. Help us make a decision. Or making a decision based on data points. Unfortunately, the adversary has been using those techniques and tactics for a lot longer than we've been using to protect the environment, especially in a static environment that wasn't designed with security in mind. So yeah, I guess the answer is a little column A, a little column B. I'm really encouraged that we are applying it. I wish that the business community will embrace it at a faster pace, perhaps at the pace that is being embraced by the IT side. There is still a little bit of a human has to ratify an AI finding. A human has to make the final decision as to what happens when there is a condition or breach. But I think that as we start onboarding people that have not lived a day without the internet and are used to allowing some decision making by artificial means, I think that it's going to be a higher adoption rate.
Well, Adam, earlier you talked about Windows 2008, right? And I know that's just sort of one example of lots of aging software, aging hardware that may be in some of these environments. How do you counsel clients to look at that infrastructure, those devices, and think about how to patch it, update it, keep it secure, even though that might be a costly thing to do, right?
Yeah, as we are retrofitting these environments with digital capability, right? The idea of security by design is you're broken in that, right? You already have a design. You're sitting down on the chessboard and the game's halfway in, and you've got limited moves you can make here. But I think that goes back to, again, working with really hand in hand and very collaboratively with the business groups and the OT technologists to understand the realities of the environment, to understand the patch windows and the challenges of taking outages when you can't. Frankly, we've seen some technology be rejected from these environments because they can't meet those requirements, because they need to be patched or they need firmware upgrades much more often than a device on a pole can actually realistically get. And so but you don't want to learn that after you've deployed 10,000 of them and all of a sudden, an audit of the environment shows you your risk profile is too high and you've got to take it down. But that's not the time to learn that. So it really gets to having those conversations and building the cross-pollination of those capabilities and the knowledge of operations on each side of the house.
Yeah, one thing that we're seeing also, I guess the business learned that security by obscurity doesn't work. Air gapping, I mean, there are some lines of business, for instance, nuclear, that they got to air gap everything. But the need for data, for immediate data to make decisions, I mean, pretty much, everybody's going to have to move to a shared model of responsibility at some point or another. Otherwise, I mean, they're not going to realize the potential gains of the business. So yeah, what we've seen, and at least what we recommend to our clients, the ones that have those Windows 2000 workstations, the ones that they got out of support, I mean, and if you make any changes, we can implement some security techniques. I mean, we can do virtual patching and essentially address the vulnerabilities of a device by creating a shroud of security, implementing IDS, firewalls, I mean, policies, deep packet inspection, and address the traffic as it goes into that particular system. So yeah, the ideal scenario will be for those systems to be upgraded, I mean, to a modern operating system. But we know that they're just not going to do it, A, because it's in production, and second, the OEM probably will not support it, as he said.
Well, what are some ways that CISOs and other security leaders can begin to implement network segmentation in these challenging OT environments to help, stand up a better security posture?
The CISOs, ultimately, they're the risk owner in the organization. They own the risk. When we look at segmentation or microsegmentation, it's a proactive approach to mitigating threats. I mean, you're reducing the blast radius. But how do you get there? The first thing is going back to visibility. Start with visibility, and once you see the devices, identify the attack surface, start creating smaller segments. I mean, where you can mitigate a threat as quickly as it hits the environment. CISOs, I mean, they have a big challenge, I mean, because they're the ones that get called to the principal's office, I mean, when there's a breach. But we can help people make that decision and showing the way, educate our business community in reference architecture models. There are several out there. It's IEC 62443, Purdue Enterprise Reference Architecture. I mean, there's quite a few. NIST, I mean, 800-53 and 82. So there's plenty, I mean, out there that we can reference, create a hybrid environment, and again, move to implement those techniques that ultimately they're just going to make their business operate more reliably. And that's the bottom line.
Right, and I think, I hate to ring the collaboration bell again, but I will. I think when we look at technology, so in the utility space, utilities have been very slow, if at all, to adopt the technology like SD-WAN is a good example, where they own so much of their own fiber. Many of the larger ones own literally thousands of miles of fiber. And so they are their own carrier. So the idea of going to SD-WAN so that you can replace one of your two MPLS, costly MPLS switches with a commodity internet line, and then that pays for itself. And then managing the bandwidth on the networks because to keep your costs down and QoS, that wasn't an issue. They've laid, historically 288 or 432 fiber pairs down in the ground that they own. And so they have, back in the day, they felt like they had unlimited bandwidth. It was their own network, so they didn't need QoS. They didn't need a cheaper cheaper network. So they were slow to adopt it. What we're seeing now is there's interest in that kind of technology, not for all the traditional reasons that most non-utilities use it, although there is some appetite for QoS today because traffic has grown so much. But now it's about roles-based access and SASE and visibility into that traffic to dissect it for operations and reliability of the network as much as it is for security of that network. So that's really where we're seeing, again, I think I literally heard a utility person, network lead say, well, why would we think about SD-WAN? We're not a retailer. That sentence come out, and it's not for those traditional SD-WAN, the reason why it took over in many non-utility and other industries 5-6 years ago. It's for these others, 30% of the functionality that's really adding to the security posture. But it takes that collaboration with the comms team to come up with, to identify the value of that capability to not only the network operations, but to the network security posture as well.
Mm-hmm.
This episode is brought to you by Trellix, which provides revolutionary threat detection and response. Trellix enhances your cybersecurity resilience with XDR so you can detect and respond to threats quickly, modernize SecOps, and defend against ransomware.
Well, I imagine that CISOs out there in this industry have continual work to do to have OT leaders really think about how they bake security into operations without disrupting existing functions or activities. And also, we're talking about new stuff, that security by design sensibility. How do you counsel organizations to start thinking that way and really build that into their culture and their behaviors within the company?
Well, there are certainly some areas where you can start by showing value and then getting into the conversation. So we talked about patching recently, in a previous question. With so many modern assets, modern technologies being deployed into the field, it's gone from appliance-based devices or appliance-based solutions where it's one OEM, the whole stack is in one device. If you have an issue, you call that one OEM. And now it's a device with an OS, with a data layer, and then a bunch of applications on top. And so there's a lot more to manage there. And then from a patching standpoint, there's a lot more to patch. And I always come back to this just because it's so tangible, but there's other examples like this as well. Well, most of our peers on the line of business don't know how to patch at scale. And there are, in many of these OT environments where the SIP protection rules are enforced, you have a certain amount of time between a patch being released and when it has to be implemented. And as the number of devices grows and the frequency of that patching grows in those devices, then they are starting to get buried under a mountain of work orders to go do those things manually in many situations. The security team and the operations teams on the technology side can come in and offer help and take those, implement best practices from IT to help drive the manual effort down and the time down there, albeit side by side with the OT group to make sure they're staying within the sort of guardrails of operations, making sure that you don't have too many outage windows or issues related to that. So I think that's an area where they can lean in and offer support and take work out of the hands and off of the plate of these already spread thin operations teams. And in doing so, they start to get into the mold of, what other solutions can we provide, and have that conversation. Like, what else is difficult? Like, secure remote access is something we've been seeing recently come up, where there's some new tools out there that can allow for secure remote access in a way that allows, in a storm, you go with a box, you plug it in, you have a tech in the field, plug it in, and let somebody in a centralized control center access a SIP medium or SIP high environment remotely. Well, historically, that was an absolute non-starter. That was not allowed. But the technology has advanced to enable that kind of functionality. That's an idea that the security teams can bring to the line of business that will help the line of business be more efficient and effective at their job without needing incredible over-the-top massive investment. And again, it's showing value as a security team and not just being that group that shoots down modernization.
Yeah, CISOs, when they are given the responsibility of OT, is really interesting, because they coming from the IT environment and giving OT as a responsibility, the first thing that they learn, and honestly, this is a process of education, IT is a service to the business, while OT is the business, especially when we're looking at power generation and distribution. That is the business. So one of the many advantages that we have here in WWT when we have those conversations and we try to educate the CISO community is that we have the ATC. When we start talking about modernizing the grid, we can actually show them how to do it in a controlled environment. In a place that they can, when they try to sell tools, techniques, security principles to a community that typically are not very embracing of change, the ATC can help them a lot, I mean, massively. Going there and demonstrating, this is how you do it, this is how you can make a stage, or stage, I mean, the deployments, we can do massive deployments, or I call it exponential deployments, right? I mean, 1, 2, 4, and exponentially grow. We can do that, we can show that in the ATC and create those models in a safe environment. I don't want to do air quotes, but I probably do air quotes, right? In that safe environment, that when they propose it to the board of directors, propose it to the business. I mean, there is some data, some valid data behind it. It's empirical data that they can use and use that with the business. Well, yeah, that part is we find ourselves educating CISOs when we talk to them.
Mm-hmm. And to that point on education, those CISOs have to be, and their teams have to be educating the business on the threat. I think they hear about, there is an unlimited number of threats to these environments. Cybersecurity, physical security, environmental, right? You cannot protect against 100% of these. And security is always a risk assessment, right? How much risk are we willing to take on, and how much would it cost in both real dollars as well as operational complexity to protect ourselves from? Right? The most secure grid is one that's not on, but that doesn't help anybody. So within those guardrails, trying to think through, to educate what are the real meaningful risks, and sorting through what the potential is, but then also educating the organization on the growth of these risks based on recent investments in digitization and other initiatives that they need to take on as the grid continues to modernize. So I think that's really, I can't underscore enough the education side. And to Carlos' point about our labs, one of the reasons we built them is to be able to demonstrate for folks, not just talk about it, but show on a control system how a specific attack works and what the implication of that is, and then what it takes to protect against it, so that it's no longer theory, right? It's not just, hey, you don't want to be the next MGM or the 2015 attacks on the Ukrainian grid, or the recent attack on the water utility in Florida, right? You don't want to be that. Well, let us show you what that really practically looks like on a control system, and how crippling that can be, where it comes from, and then what it takes to be protected from it.
All right, gentlemen, last question for you. If you look ahead, 2 years out, 5 years out, near future, what's one thing you're worried about, one thing you're excited about relative to security in energy and utilities?
I would say AI. Yeah, AI to me, right? And this is part of Carlos's answer to that question earlier. It has the potential to drastically improve visibility and understanding of what's going on the grid. As we get vastly more amount of data coming in and more context, and we start to integrate the systems across things like ADMS and OMS and EMS, the renewables, DERMS, and we start to really see the full picture, even our AMI platforms. That data can be used to identify risks. It's also 100% being used to enhance those attacks and drive complexity into the adversarial actions being taken by state actors and others. So that to me it is the biggest strength coming into the industry, and it's also the biggest weakness. Getting a handle on how to go implement that and protect against those attacks is going to be huge in the next few years.
Mm-hmm. Yeah, I think that AI, again, that is the word of this decade, right? AI, but it's going to be implemented in an environment that has fractured security at best. So the implementation of AI, it takes a lot of planning, and utilities are lagging behind the rest of the industry in security, no doubt about that. Our critical infrastructure right now, it's the security is fractured. There's a lot of modernization that needs to happen in order for AI to be effective, if you want to call it that. A lot of companies, a lot of OEMs, they have that in their roadmap. So the implementation of AI definitely is going to trickle down at some point. What encourages me is that the grid is an enabler. There's a lot more that can happen using the power grid. And there's a lot of demand. The demand and the consumption model is going to change in the next 10 years. There's a lot happening that literally, with adoption of EVs and all the connections that are going to be into the grid, consumption is going to increase, and the attack surface is going to grow exponentially because of what is expected of the grid now.
Adam, Carlos, thanks for being here today to share your expertise. I really appreciate it.
Thanks for the opportunity.
Thank you for the invitation. Mahalo.
And thank you for being here as well. Another great episode, one of 4 in our series on energy and utilities. Please join us for the other ones. Check those out on WWT.com or on artificial intelligence, lifecycle management, and operational technology. Lots more out there on WWT.com in terms of content for you to watch at any time on demand. More coming up on the calendar, so you can join those events and watch them when they're released. And we'd love to hear some feedback from you. So please do take that survey if you get an email, or just drop us an email and let us know how we did. And with that, we will wrap for today. Thanks for coming. We'll see you next time.